All right, let's get this on the road. It's day 17 of 100 Days of ML. Today I'm going to be focusing on ML ops production. So I'm going to be referring to the website Made with ML, and under ML ops, the topic called production. So let's get started, I guess, with dashboard. Creating an interactive dashboard to visually inspect. Okay, using Streamlit. Hmm. So this is what is this, like a dashboard that describes how the model is doing in production? Processing performance quite well, but how do we effectively communicate this to other developers and business stakeholders? Okay, so they're using Streamlit to create the dashboard because of its intuitive API sharing capabilities and increasing community adoption. All right, we've already set up Streamlit, so this should be fairly quick. And then we can call this dashboard. I think I'll use Sublime here. App.py. Okay, got that set up. We need to learn about the different Streamlit API components. Okay, their API reference. They have a bunch of different APIs, I guess. Display. They have latex. It's nice. Write. You can write a direct data frame into Streamlit. It accepts charts as well. title. I mean, you get the idea. There's like a bunch of things you can display. Okay, this is the dashboard code he uses. It's a lot of things. Load the data and then display it. Can display a data frame. Walk viewers through the entire data set, data phase. Minimum tag frequency. Okay, let's see. All right. First, displaying data. Okay, performance, get tags. I want to see what this page looks like. Is it deployed or is it just local? Hmm. Gotta import Streamlit. This is the home page. Info shows up like this. This is the title. Suppose they select data. So it just displays it underneath. And then you can display whatever type of data you have. He displays like all sorts of pre-processing and other information about the data set. Okay, I think I get the gist of it. CI/CD workflows. Okay, using workflows to establish continuous integration and delivery pipelines to reliably iterate on our application. Continuous integration allows our team to develop, test, and integrate code in a structured fashion. We can develop and deploy knowing that our systems can quickly adapt and work as intended. Jenkins, TeamCity, Circle CI, GitHub Actions. GitHub Actions is free. So you get about 2,000 minutes per month and 500 megabytes of storage with GitHub Free. If you have Pro, you get 1 gigabyte and 3,000 minutes per month. And if you pay for more, I think you can get more. .github, workflows, and testing YAML. Did I create that somewhere? I don't think so. Name testing, triggered by an event, which can be something that occurs on a schedule, webhook, or manually. Push and pull request webhooks to run these testing and workflows. So on push, branches main, pull request, branches main. So test code, which runs on Ubuntu. Check out the repo, install the necessary dependencies, and run tests. Okay. Guess there's a whole section on deployment as well. That's the next one. So I guess we use Google Kubernetes Engine. I think we can automatically update our application when the integration tests pass. So whenever you commit to GitHub and suppose all the checks pass and you merge the pull request, it automatically updates the container on Google Kubernetes. Okay. I think I need to read more about this. Might watch a couple of YouTube videos on this as well. Okay, what's next? Deployment? First decision to make to whether serve productions via batches or real time. So batches give you a low latency interface. Inference. Then we can have real-time serving to HTTPS call. So more up-to-date predictions and meaningful user experience. So I guess in batches, it's kind of like offline. computes everything offline and then stores it in a database, and once you access the website, it serves whatever is already stored. Whereas if you have real-time serving, you have to provide the real-time data and then process it and return back the results. And then we can do offline learning or online learning. So offline learning, we train it, and then after evaluation, we deploy it. No urgency. Whereas online is happens frequently when the API is called, I'm assuming. Perform A/B testing with comparing the two models' outputs and evaluating which one's better, I guess. So this is a gradual rollout system. Here it's like 50-50, I think. And here we're sending the same traffic, just duplicating it. And new systems not served to the users. The way we process our features and serve predictions dictates how we deploy our application. So we can deploy it through compute engines. Easier to deploy. It's not easy to scale. Container. Okay. So yeah, this is kind of what we did. Google Kubernetes. It's easy to scale. Can introduce complexity. Serverless is no need to manage any servers, and it scales automatically depending on the request traffic. Real-time serving, stream processing, offline learning. All right. Good stuff. I'm not sure why these links don't work anymore. It might have been removed. Alright, I think I'm gonna end this stream early today. I feel extremely tired. What I'm gonna do is continue learning, but watch YouTube videos, because that way I don't really have to think that much. Information's just fed into my brain. So here's what I'm gonna do. I'm gonna update this. Let me just make sure that my repository is up to date. Okay, so today, so day 17, read about ML production. So I'm gonna do li. The heck? Okay, Sublime Text 4 does not have autocomplete for HTML. What's going on? That's whack. I just updated it. What's going on? I have to look into that autocomplete. Okay, so what I'm going to do is learn more about CI/CD. And that'll be it for today. Right, so tomorrow I'll continue with reading building ML pipelines. I'll read chapter 6, which is model training. And I guess reinforce my learning by reading online resources on whatever it is that uses, I think it's called Trainer, TF Trainer or something. But yeah, that's it for today.